Welcome back everyone to the Hello World Guy, and this is episode number 7 if I'm not wrong of our great game that we were making about this memory based puzzle game. And in this video, this is a short video but it's going to be rather interesting. In this video we are going to create an animation for our all of the tiles. So currently you can see that if I click on one, okay, I made a little bit of changes in the code for debugging. Let me just fix that. So the point is that well, when we actually do this, it doesn't actually work that well. So our they just currently change. So these change extremely quickly, which is not exactly what we want. We want them to change slowly and steadily, and that is what we actually would like. So yeah, we need to fix that. Let me just remove this line of code. I just added it extra. Now let me open up my clear script, and for this let's start off by going in here where we are unlocking the tile. So you can see we are unlocking the tile and then we are unqueuing it. But instead of unlocking the tile, I'm going to go ahead here. I'm going to create a private enumerator called init called let's just say call it turn tile, and it's going to have a tile called tile. And all it's going to do is it's going to go ahead and say yield return new. Okay, so first of all, let me just go up, and I'm going to add in a couple of serialized fields here. Let me just add a space after these, and let me add a couple of more. This is going to be our animation time, and we don't actually, let me just remove this and this. We don't need any of these. We don't need that space either. It's just we need this animation time. Now this animation time, what we will do is we will do new wait for seconds, and we will wait for the animation time. And yeah, that is pretty awesome. Now animation time divided by 2, by the way. We will come to see why that is in a minute. So first thing that we will do is what we want is we want to change the size. So first of all, by the way, after waiting for half of the time, we are going to say tile.unlock, and then we are going to do it again. Let me just show you. First of all, first thing is to oh, by the way, just change this to anytime. For now we will find out destroying later. So in here, what I'm going to do is I'm going to go under here, and instead of doing this, I'm going to say turn tile, and I'm going to pass it my tile. Alright, so in here you can see we're calling tile.unlock, but before we do that, we want, so first of all I'm going to go up here, and I'm going to have a private let's just actually, I've got an interesting idea here, which is that we are going to have a, so let me go here in the tile. We are going to have a public thing here. We've got our public tile type here. I'm going to go ahead here, and I'm going to add a public float called target size, and we are going to have it get and set as well, just a direct property. And this what this is going to be is going to be our target size, and in here I'm going to add in a update method. Before, after all of these, I'm going to add in an update method, and what we want to do in this update method is that we essentially want to make sure that we are always, so first we can just say float size is equal to we need to basically have it interpolate from the current size to the target size. So how are we going to achieve that? Well, using some linear interpolation, of course. Alright, so first of all, I have added two more variables here, a start time and a start size. Now this start size is, by the way, private, while the start time is public property. And in the update method, what we do is we go ahead and say start time. Alright, so we go ahead and say transform dot position. Oh, by the way, I just realized something. We actually need to make the start size public as well. We might, but I don't think we actually need to make either the start time or the start size public. So we are going to make them both private. Just normal floats. And what I'm going to do is I'm going to add a public void here called start animation, which is all I'm going to do is it's going to set the start size, which by default let's just set that to 0, and actually yeah, let's just set that to 0 and set the start time to be 0 as well. Now let's go ahead and say the start size is equal to our transform dot local scale dot x, and what we are going to do is we are going to say start time is equal to time dot time. And what we are going to do in the update method is that we are going to say transform dot local scale dot x is equal to okay, we need to we can't do this, so we have to say, well, first of all we need to say okay, we have to create a vector 3 called scale and set that to transform.local scale, and in the end we need to say transform.local scale is equal to this scale. And what we need to do within this is we need to say scale dot x is equal to mathf dot lerp, and we are going to use this to provide it with a starting value which will be our start size, an ending value which will be our target size, and a float called t which will be time dot time minus our start time. All right, and what we want to do is we want to go lerp, and yeah, that seems to work, and this should actually work for most of the time, let's hope. And of course our target size by default is going to be, can we set that it's like that? I doubt. Okay, okay, can you set it like this? Nope. Yes, you can. All right, so this target size by default is going to be, well, we don't want it to be 0, of course we want it to, okay, so what we are going to do is we are going to, in the init method, we are going to set the remove that, set the target size is equal to our we are going to actually call the start animation function. First of all, we are going to set this to be equal to our start size, and we are going to call our start animation function, so which that would allow everything to be set correctly. So this is going to work, and what we want to do in the turn tile is, let's say that we all right, we actually don't need the target size to be public either, just make that private as well, remove this and remove that as well, and in here we are in the start method, we can just start animation method, we can just say a float called target size, and we can set our target size is equal to that target size, and we can maybe make it an optional argument and make it 0 by default. Oh, this is supposed to be this the target size. All right, in the in here we are going to say target size is equal to our start size, and that should work. So now in the they're still giving an error. All right, target size, I should have used rename, I guess. All right, so in the player script we can just call tile dot start animation, and we can give it a target size of well, we want it 0, so we can just give it target size of that, and let's see how well that works. Alright, so I made a few changes here to the code, and in here you can see that in the mathf.lerp function, instead of using the time.time minus start time directly, we are dividing it by another value called time. Now this time value is a private float here, which also happens to be an argument to the start animation function which we set it. This will allow us to, oh, by the way, why is called speed, it's supposed to be called time. Alright, and what this will allow us to do essentially is will allow us to control how fast the animation actually plays. And in here you can see, by the way, I made a mistake. I called the turn tile method directly. You need to start coroutine it, and in here you can see we are just starting the animation and with 0, and the animation time as the time, and then we are waiting for the animation time. You can divide it by 2 if you want, and I am unlocking the tile, then after we have the tile at exactly 0 size, and then we are starting the animation again with a size called default size, which is a serialized field, and we are providing it with the same time. You can divide all of these values by 2 if you want to, and that should allow you to have an actual time, but we are not going to do that. I'm going to go under Unity and let it compile, and you can see in here I have set the animation time to be 0.2, while the default tile size is 1.5. You can set it whatever tile size you have, And once I hit play, what you should see is that it works. It actually did not work that well. Let me go in here. We start the animation with the default all size for the animation time. All right. When it was reappearing, it did not work that well. Let me see. Let's just hit play again. By the way, I am going to increase the animation time to 0.5. That looks a bit better. Slower animation. All right. You can see that it's working, and it looks like this. So this is nice, and you can of course make it a little bit faster if you want to have this fast kind of effect, which is pretty nice. So this is all right, working all is perfect here, and we are going to actually complete this whole system and make it look absolutely great in the next video. In this video, all we are going to do is we are going to end the video here. So I will see you in the next one. Make sure to like and subscribe. Also check out my other channel, link in description, and I will see you in the next video. Bye.